So none of you were able to come up with the y-intercept for this guy? Okay. Shouldn't be that hard. Okay, what are you? Okay, so what did we say about the slope for this? What did we say the slope last time we had the slope?
-4/3.
Okay, so we know the y-intercept has to be somewhere between 1 and 2, right? We're just not sure entirely. Honestly, I'm not sure if it's halfway through or not just by looking at the graph. So if we have the slope, we know the 2 points, right? We can identify 2 points on the line. What other technique can we use then to come up with the y-intercept? Or basically, our goal is honestly to find the equation rather than the y-intercept.
Plug in a point and solve for the y-intercept.
I mean, technically, you can plug in the point and just come up with the equation. Remember, we looked at the point slope form last time, which was on page 2. Because our goal really is to find the equation of the line, right? It's not really to find the y-intercept. Having the y-intercept makes our process easier. But if you don't, you can always fall back on this one because we already obviously have the slope. So give me one of those points. Which one would you like to use?
Let's use -2x and +4y.
Okay, so you're looking at this point right here. Yeah? So yeah, you can use -2, +4. Obviously, you can also use this guy here, which would be 1, 0. But since you want to do the other one, we'll use the other one. So let's use the point -2 and +4. So of course, those points or those values will substitute our x1, y1 in the equation. And then we already have our slope, so that should give us y minus y1. y1 is +4. Your slope is -4/3, so that's the m. And then x minus x1 is -2, so make sure you take that into account. Okay? So basically just cleaning this up, of course, our 2 negatives here in the parentheses will end up becoming positive. So you've got y minus 4 equals -4/3, parentheses, x plus 2. Now what would you do next? Distribute that -4/3, very good. So take that guy, multiply with the x and with the 2. So that gives us -4/3 times x is -4/3 x. And what is -4/3 times 2? -8/3, yeah, very good. Because you end up multiplying the -4 with the 2, which gives you -8. And then 3, technically you don't have a denominator, so 3 stays the same. And obviously 3 does not reduce 8, so you leave it as -8/3. All right, what's the last thing we gotta do? Okay. Sorry? Yeah, get y by itself. So since we have that -4 with the y, we're going to move the -4 to the other side. So what do we do?
Add it.
Very nice. Add that 4. And of course, that 4 will be added with the -8/3. And you should end up with just y on the left-hand side. -4/3 x will stay the same. And then we are adding -8/3 with +4, which you can think of that as being 4/1. So what's our next step to add those two numbers together on the denominator, which will be 3, yeah. So taking the 1 and the 4, multiply that by 3, you're going to end up getting 4 times 3 will give you 12, right? So you end up with 12 thirds. So what's negative 8 plus 12? Positive 4, yeah. So you're actually going to end up getting positive 4 thirds as the answer from adding those two numbers together. So you can see we are back into our y equals mx plus b form, right? The slope-intercept form. Of course, your slope stays the same, negative 4 thirds, but looks like our y-intercept actually came out to be, if you convert this to a decimal, you get 1.33333. So it wasn't really halfway between 1 and 2, right? It's a third of the way through. So it would be hard for us to identify this just by looking at the graph of our function. So in this case, we were not able to use the y-intercept, so we went back and used the point slope form of the equation to help us come up with the equation. Question on this guy? So that's of course your final answer that you're looking for. Okay, so that was number 8. Okay. We had of course talked about number 9 last time, right? So basically that takes care of that section, and I don't know why this guy's not moving. Okay, so this one again is basically asking us to take our equation and put it in the slope-intercept form. Remember again, your slope-intercept is the y equals mx plus b. And then once you get it into that form, they want us to be able to identify what the slope and y-intercept is. Okay, why are you doing this? Okay, so what would you need to do to write that first equation, 3x plus 5y equals 15 into y equals mx plus b form? Yeah?
Divide both sides by 5.
Before you do that, divide both sides by 5. Before that?
Subtract the 3x.
Yeah, I would actually start by moving the 3x to the other side, so you already get it out of the way. And then you would need to divide both sides by 5 to get that. Okay, so I'm actually going to let that one be. This is the two that I really want to talk about because that one actually is not that hard. What are we going to need to do here in number 11?
Distribute everything on the right side.
Distribute, yeah, and then of course go ahead and make those two negatives a positive, right? Okay, so let's take a look at that guy. Then you've got two negatives, which will end up becoming positive. Distribute that negative 3. Pretty much the same thing we did in number 8. And then the very last thing you would do is get y by itself, right? If you want to get this in y equals mx plus b form, you would subtract that 5. It's really just about cleaning up your equation. So what's our slope? What's our y-intercept? Slope comes from which number?
The number is
Yeah, it's always the coefficient on x, right? So since my x has a coefficient of negative 3, my slope will also be negative 3. So the sign goes with the number. And y-intercept? got to be the other number, the one that is the constant. And remember, you always write x and y intercepts as ordered pairs. So x is always 0, and y is -8 for the y-intercept. So in that same sense, you should be able to identify the slope and the y-intercept for number 10 as well. Okay, what do you think is going to happen on number 12? -y plus 5 equals 0. What will you do to get y by itself?
Subtract 5.
Subtract 5, very good. Okay, but now I still have that negative sign on the y.
Divide.
By 1. Yeah, -1. So that you can get rid of this negative sign on the y. So this is just y equals 5 then. So what is our slope and y-intercept? Are we seeing an x term? No, right? Because there is no x term. So what does that mean? What kind of slope do we have? No slope.
It just makes a straight line.
It is a straight line. It is a horizontal line. I heard somebody say that. So what kind of slopes do horizontal lines have?
0.
0 slope. Yeah, so you will actually have a slope. It's just going to be number 0 because the idea is 0 times x becomes a 0, and that's why we don't have the x variable here. The only line that has no slope, or which we call as undefined slope, is a vertical line. Okay? And what's our y-intercept for this guy then?
5.
Yeah, it's going to be the ordered pair. 0, 5. Okay?
Do we have to do the ordered pair for every answer like that?
For y-intercepts, x-intercepts, yeah, you always write them as ordered pairs. And you will actually see, even in my math lab, it will ask you to type an ordered pair. Okay, let's see. You know, they updated the software and now it doesn't want to do what I want it to do. Okay, what would you do for finding this equation, number 13?
Put it into the form for y equals mx plus b.
Okay, if you use y equals mx plus b, where would you be entering the numbers?
The 4 would be your x.
Okay.
And the -6 would be your y.
And slope would be m, right? 1/4. Okay. So you can actually use y equals mx plus b to come up with the equation, but what it's going to do is, as Brandy mentioned, the x and the y will take your 4 and -6. M, of course, is your slope, which takes the 1/4. So in y equals mx plus b format, you will actually then be finding the b if you use that equation. So find your b, and then you would have to put it back into the form of the equation, or do what you did for number 8 and use the point slope form. So you can actually do it both ways and come up with an answer. So since we use the point slope form in number 8, let's do it the other way here with number 13.
Now, how would you decide which one to use that would be simpler? I would say.
You know, I think it really, honestly, Levi, comes down to preference. So if you prefer the y minus y1 equals m times x minus x1, the point slope form, you can use that. To me, they both seem equally easy. So it's just what your preference is. Because I have seen students who will do what Brandy just talked about, using the mx plus b format and finding the b and then putting it back into the equation.
Is there any rule that would separate from using one to the other?
The only time it would be separate is if you were only given 2 points and no slope. So in that way, I would probably then go, well, it really wouldn't matter because you would still have to find the slope. Because you would still have to find m to use any of those equations. So I don't think, yeah, it would honestly matter then. You could do either or. Okay? All right, so let's see. They are telling us that the line is going to the point 4, -6, and the slope is 1/4. So if you are using y equals mx plus b, then this will of course be your x and y values. So we would have y as -6, m, your slope is of course 1/4, x value is +4, and then like I said, you're basically finding the b value in this case. So -6 will stay the same. What happens when you multiply 1/4 with 4? Comes 1. It will become 1 because you can actually think about that 4 as being 4/1, right? So you can either multiply across and get 4/4, which reduces down to 1, or basically your 4 and 4 cancels each other out, giving you 1. So either way, it's going to work out however you want to look at it. And then of course, plus b. Now what do we do to get b by itself? Subtract 1. Very nice. Subtract 1. And our b value comes out to be -7. So now that you have your b value, you just have to literally fill in the blanks. So y equals mx plus b is our slope-intercept form. We already know the slope because that was given to us. So that's going to be the 1/4. Now this time, your x and y will stay as variables, x and y. You don't plug in any value, and we know our b came out to be -7. That's your equation. And then like I mentioned, the other format would be using this equation, putting your x1 and y1 with the 4 and -6, and then of course your slope of 1/4. That would be the other way to go about doing this. Question on number 13. Okay. So this one here is just talking about how you can use the slope to actually help you with the graphing. And I've kind of mentioned this before. So as you go from left to right, your positive slope makes your line go up. If you go from left to right, a negative slope makes your line go down. And then of course, horizontal lines have 0 slopes. Vertical lines have undefined slopes. So I'm not sure if we're graphing a vertical line or not. So they're basically saying, how can you use the y-intercept and the slope to sketch your graph? So what happens in this case, and again, this is something you should be familiar with, you always start by using your y-intercept as your starting point, and then using the slope, we try to come up with our other points, right? So the y-intercept always ends up being our starting point in this case. So what's your y-intercept and your slope when you look at number 14?
Your slope is -2 and your y-intercept is 1.
Very good, yeah. So let's go back here. Okay. And this is going to be a little off because I don't know why it's not working with my alignment again. So starting with 0, 1. Now, where would you go with that slope of negative 3/2?
You're gonna go back 3 and then up 2. Is that what you're asking?
Yeah, like what direction?
Oh, to the left
To the left 3?
and then up 2.
First quadrant.
Yes, quadrant 1.
Okay, let's think about that again. Our slope is always rise over run, which means the numerator always gives you the rise, right? Which means up or down. And the run is your left and right movement, right? So that means instead of going left, then where should we be going for negative? You want to go down. So if this helps you, you can kind of think of it this way. If it's positive slope, you are always going up and right? Because you go up positive, go right, which is also positive. But you know, sometimes if there's no room on the right-hand side, you can actually go down and left, and you will still be on the same direction. Okay? Now, if you're talking about a negative slope, which is what we have here, let's say we still want to go up, but because of that negative, instead of going right, you would now go left. So one of these directions has to change. Or instead of going up, if you want to go down, you can do that, but then that means you are still going right. So like I said, only one of those directions has to change. So in our case, let's say we're at our starting point here and we want to go up 3 units. So that's 1, 2, 3. Well, I don't actually need a point there, and I'm still going. I went up, so I should be going left 2 units. Somewhere over there. That should be your line. Hopefully you guys will have a little bit of a nicer line behind it.
So when we said the first quadrant, that was correct, right?
Second quadrant.
Oh, that's the second.
Right, because remember we go in counterclockwise direction, so this is 1, quadrant 2, 3, and then quadrant 4. So we didn't actually need this point here. That was just me counting.
I went down 3 and then over 2.
So if you did down 3
Because it's a negative.
and right 2, you should have ended up somewhere on
So I
this
did it
point,
right,
right?
yeah.
So yeah, you should still end up on the same
Okay.
point, definitely. Okay. Any other questions on 14? So obviously my graphs are not coming out how I would like to. Now, where would you start with number 15? Y equals 4 over 3x. Because there's no plus or minus number, right? So usually what does that mean? Where's your y-intercept? Yeah, it's going to be at the origin, right? It's at 0, 0. So for this graph, you're actually going to start. Let's see, it's not working. So you will start at the origin 0, 0, and this is a positive slope. So where would we go? Up 4? Very good. Yeah, so start at 0, 0 as your y-intercept, and then you would go up 4 and right 3, or you can also go down 4 and left 3, but you would still be on the same line. Okay? So I'm not going to attempt graphing anymore since my graphs are not coming out how I want them to. So that guy shouldn't be too terrible. And it's a positive slope, right? So your line should be going up from left to right. 15. So you're starting at 0, 0, going up 4 and right 3. Bless you. Okay, so did we all get our line? Okay. Okay, what do we need to do for number 16?
Get y by itself.
You want to get y by itself, yeah. So start by again moving your 2x to the other side. So that will leave us behind with negative 3y. We've moved the 2x to the other side, so that became negative 2x. Your 6 is a positive number. It stays positive 6. Okay. Now what would we do? Okay, so what would you do? I would actually just divide by negative 3, right? Because we don't want the 3 to be on the y either. So just divide both sides of your equation by negative 3. Basically, each of the terms will get divided. Negative 3 and negative 3 cancel out, leaving us behind with just y. I have two negatives here, negative 2 and negative 3, so they become positive. You end up getting 2/3 x. And then what happens with positive 6 divided by negative 3? Very nice. It will become negative 2. So your slope is going to be 2/3. And the y-intercept is going to be 2. I will try one more time, but I am not very optimistic on what this is going to end up looking like. So of course your starting point is the y-intercept again at 0, negative 2. Okay, so this side seems to be better. Where will 0, negative 2 be? Left.
0, negative 2. Left.
Be down. 0, negative 2 will be negative 2 on the y-axis, right? And then this is still a positive slope. So that means you are going up and right. Or of course you can go down and left. So if I go up 2, right 3, or if I go down 2, left 3, I should be somewhere over there. Anybody have questions on that? Number 16. What are you going to do for number 17? 6 minus y equals 0.
Y by itself.
Okay, subtract 6, okay?
Negative y equals negative 6.
Negative y equals negative 6.
Divided by negative 1.
And then divide by negative 1, which will end up giving us y equals positive 6. Yeah, so honestly, you could have also just added the y, right? And just moved him to the other side and you would have y equals 6. So that would also work. And you can always rearrange your equation to y equals 6. So what kind of line is y equals 6? Because again, there's no slope, right?
No, otherwise, this one's horizontal.
Horizontal. X is the vertical line. Y equals is the horizontal line. So you're basically going 1, 2, 3, 4, 5, 6 and drawing a horizontal lines do that. And don't feel bad, because that is probably one of the biggest confusions I always see, is which one
Yeah, I
is
just put the
horizontal and which one is vertical. So basically the idea is if you're getting y equals 6, you're basically crossing the y-axis,
I just
right?
put my point on
And
there.
if it's x equals, then it's crossing the x-axis. So if that helps, kind of think about it in that sense. Okay? Alrighty. So this is just a summary of the 3 forms of your equation of a line. Of course, we have the standard form, which is what we started out with. The slope-intercept form is probably the second most common form of a line that we see. And usually, even though we call this the form of an equation of a line, you don't really see equations left in that form. Usually, we'll start with the slope-intercept form, but then either convert it to the slope-intercept, y equals mx plus b, or put it in the standard form, which is your ax plus by equals c. And you can kind of read some of the other information that we have up there. So we're not going to be solving these. I think we've done enough examples with that. But what process, where would you start with number 18? Which of the equations would you use?
I would say the slope-intercept.
Okay, so basically same thing, you would start by finding the b and then putting it back into the equation. Obviously, you can also use the point slope form, because we do have one given point and the slope of the line, so you can use that. Now, this is kind of, Levi, what I was talking about. So now if you have only 2 points given to you, no slope, where would you start?
0.
Mm-mm.
You don't support the slope.
You do want to start by finding the slope. Yeah, so the first thing you would actually do is go back to the slope formula, which you remember was n equals y2 minus y1 over x2 minus x1. That should be in one of the first pages of this handout. Page 1, yeah, right at the bottom of page 1, you have the slope formula. So that's where you want to start, is finding the slope first. Once you find the slope, then use one of the 2 equations, point slope or slope-intercept form. All right, so the last part I want to talk about is the idea of what happens when 2 lines are parallel or 2 lines are perpendicular to each other. So let's look at this number 20 here. Now, the crucial thing that we're actually trying to get, the information we're trying to get out of this is the fact that parallel lines are always going to have the same slope. Because, you know, the idea is they're running alongside each other, right? The distance between the 2 parallel lines is always going to stay the same. We always use the example of railway tracks. If you want to think of parallel lines, right? You really don't want those tracks to go away from each other or go towards each other where the distance changes, because that's when bad things happen. So it's the same idea here. If you're talking about 2 parallel lines, then we're basically saying that the distance between the 2 lines is always going to stay the same. And, you know, obviously they're going in the same direction, so they're going to end up having the same slope. So what this example here is asking us, they're saying find the equation of the line that goes through this point, but is parallel to this other line. So the idea is we know the point through which the line is passing through. So that's good. But we don't know the exact slope of our line. They're just telling us it's parallel to this other line. So this is where that idea of saying slopes comes into play, which means whatever is the slope of this line, that's going to be the slope of our line. And that's the only information that we're getting out of this parallel line. So if we had to basically find the equation for this line, this is number 20. So the point that the line passes through is 2, 4. The parallel line is given to us as y equals -1/2 x plus 9. So if they are parallel lines, we know they have same slopes. which means the slope of our line is going to be the same as slope of this line. So what's the slope for this guy? Very good, -1/2. So that's the slope for our line, and that's really all the information we need from that other line. So again, you can use y equals mx plus b, right, to come up with the equation for our line, or you can use the slope-intercept form. So let's actually fall back to that one since we did the y equals mx plus b last time. So in this case, this guy would be my x1, y1, y minus 4, slope is -1/2, x minus 2, right? So we don't really have anything to clean up, which means you can start directly by distributing this inside the parentheses. That would give us -1/2 x, and what's -1/2 times -2? +1, yeah, the two negatives will become positive. 1/2 times 2, basically think about it as canceling out, or if you multiply, you get 2/2, which becomes a 1. And then the very last thing is yeah, move the 4 to the other side, get the y by itself. Which will give us y equals -1/2 x plus 5. And this is the line we were asked to find. So you should notice that our two equations for the two lines that were parallel will have the same slope but different y-intercepts, right? Because if you're talking about parallel lines, they are a little bit of a distance away from each other, so they cannot have the same y-intercept. So they'll have the same slope, but they will have different y-intercepts. Questions on 20? So those are parallel lines. What kind of slopes do perpendicular lines have? So it's kind of interesting the way your textbook defines this. They are saying basically the idea is if I take a product of my two slopes coming from the two perpendicular lines, they're going to multiply to be -1, which actually means that the two slopes are going to be negative reciprocal of each other. So if one slope, just going back to our previous example, so the idea is if one of them is going to be -1/2, the second slope for perpendicular line has to be +2. So they're negative reciprocal, which means if this guy is negative, the other slope has to be positive. And if this guy is 1/2, the other one has to be basically 2/1, or basically 2. So you're inverting your numbers and then changing the sign for perpendicular lines. So again, it's the same thing. They're asking us to gather what kind of slope we can get when the two lines are perpendicular, and then of course they're telling us the point to which our line passes. So to try and solve something like 21, the point that is given to us is -2 and 1. They're telling us it's perpendicular So perpendicular lines have negative reciprocal slopes. Or basically, like your textbook is saying, when you multiply the two slopes, your answer should be -1. So to be able to get the slope out of this line for the perpendicular line, we need to get again y by itself. So you can start by subtracting 2x, or just to show you a little bit of a different calculation, I'm actually going to start by adding that y and moving the y to the other side. So we are left behind with 2x equals 8 plus y. And we're trying to get y by itself, so you're basically subtracting the 8. And we end up getting 2x minus 8 equals y. And then you can rearrange it if you like as y equals 2x minus 8. If you want to do it the other way, start by subtracting the 2x and then divide everything by negative 1. You'll get the same answer. So this is just a different way where you don't have to mess with dividing by negative 1. That's really the only difference. So for this line, and let's call that slope 1, the slope of this line is 2. So the slope for our line, what is it going to be if we're saying the slopes are negative reciprocal for each other?
-1.
Yeah, so since this guy is 2, you can think of that as being 2 over 1. So if he's positive, the other slope has to be negative, and 2 over 1 will become 1 over 2. So you have to remember to invert your fraction, or basically flip it and then change the sign. So the slope of our line is going to be that m2, which is negative 1/2. And then again, you have the option of solving with the point slope form or the slope intercept. I'll show it to you with the slope intercept this time. So obviously in this case, the x and y values will now come from the point. Y is 1, slope is negative 1/2, x is negative 2, and you're finding the b value. What will that b value come out to be? 0? Really? Okay. What does this give us? Negative 1/2 multiplied by negative 2. Yeah, 2 negatives will become positive, and then your 2's will technically cancel each other out. So that ends up becoming positive 1. You don't really have to write the positive. And then when we subtract, to get b by itself, you subtract that 1. And as you will see, it actually cancels out, giving you 0. So if b came out to be 0, what's our equation going to look like?
1, 2 over -1.
Yeah, so remember at this time, you don't put anything for y and x. Our slope is still minus 1/2. B is 0, so technically, you don't really need to write that 0. That becomes your equation. So remember, even though you don't have homework on this section, you will be using all of these skills in whatever we are doing in this chapter, and of course, going forward. So you should be comfortable with the equations of the line. You should be comfortable with the slope formula. Obviously, comfortable with the different types of examples we did. If you're given a ordered pair and a slope, coming up with the equation of a line. If you're given 2 ordered pairs, coming up with the equation of a line. and being able to graph your lines based on the information you get out of your equation. So make sure if you need extra practice, you can actually go under the study plan section in MyMathLab and get extra practice for 1.4 since you don't really have a homework assignment on 1.4. Okay? Alrighty. So this is the end for that. I'm not really going to